Hello. In this video, I'll present the findings from my experimentation on the motion of a fallen object and explore the effects of gravity and drag. This lab aimed to analyze how an object falls under gravity alone versus with drag. I compared and observed data from a video with two computational models, one including only gravity and another including both gravity and drag. First, I recorded a video of a crumbled paper falling and analyzed it using tracker software to get position versus time data. This provided a basis for comparison with my computational models. My gravity-only model was implemented using Newton's second law, where I graphed the motion considering only gravitational force. I used this code section to calculate the net force due to gravity. Then I updated the velocity and position with this update of the originally provided code. The gravity plus drag model included a drag force proportional to the square of the speed, which is more realistic for objects in the air. These were the parameters I included to implement drag into my gravitational computation. I then adjusted the velocity and position calculations to the code shown, where b is the drag coefficient. After observing my actual and the two computational models, the observed data showed the longest fall time as real-world drag is significant. The gravity-only model predicted the fastest fall, while the gravity plus drag model fell slightly slower than the gravity-only model, but faster than the observed data. Terminal velocity occurs in the gravity plus drag model when the drag force balances the gravitational force. This results in a constant velocity after reaching terminal speed. The gravity-only model does not exhibit terminal velocity due to constant acceleration. If the objects were initially thrown downward, it would reach terminal velocity faster. The added initial speed affects the time to reach terminal velocity, which can be examined using our computational models. There are a few potential sources of error in this experiment. These include incorrect assessment of the distance traveled by the fallen object, potential errors in coding the computational models, and also inadequate assessment of the real-world drag on my fallen object. In summary, my observations align with the theoretical expectations. The observed data showed the longest fall time due to drag, while the gravity-only model fell fastest. The gravity plus drag model provided a realistic intermediate fall time. Finally, I would like to acknowledge the resources and tools used in this experiment, including tracker software, GlowScript for coding, and the lab instructions provided by my course. Thank you for watching.